Okay, question 2 on your review has to do with the tom-tom. Oh, I'm sorry, dom-dom. Completely different device. And the dom-dom is a device. They've manufactured many, many of them. And the mean lifespan of all the dom-doms ever made, we call mu. And it's 30.5 months. This is given to you in the prompt. The average lifespan, the mean lifetime of all dom-doms is 30.5 months, and the standard deviation is 1.25 months. So mu is the population mean, sigma is the population standard deviation, and the lifetimes of these dom-doms are normally distributed, meaning it follows the bell curve. And we'll look at that in just a second. So the first question is, find and interpret the z-score for a dom-dom. This is part A. Let x be 33 months. So there's a particular dom-dom that's selected, and it had a lifetime of 33 months. Well, what is its z-score? Well, we use our formula, z equals x minus mu over sigma. And x is 33. Mu is 30.5. Sigma is 1.25. If you do the math, you'll find that this reduces to 2.00. So that is the z-score for that particular dom-dom. And so the dom-dom with a lifetime of 33 months, that has a z-score of 2. Remember, z's don't have units. Z's are dimensionless. X, they have units. Now here's the question. What does that mean to have a z of 2? A z equal to 2? Well, I'm glad you asked. What it means is that particular dom-dom's lifetime is 2 sigmas above mu. It's 2 sigmas above the mean. Meaning it has a lifetime which is 2 standard deviations above the mean. Remember how I said that they're normally distributed? The lifetimes are normally distributed? Well, here's the standard normal curve, where mu is 0. And here is this particular dom-dom, right there. I just put a green line right where that particular dom-dom is at 2. It's 2 sigmas above the mean. So that's the answer to part A. Now, part B. That's the probability that a randomly selected dom-dom has a lifetime between 30 and 31 months. So here's part B. What's the probability that some dom-dom has a lifetime between 30 and 31 months? Well, this is our favorite kind of problem because we're looking for the area under the curve between 2 values. So I need to convert each of these limits to z's. So it becomes the probability that z is between negative 0.4 and positive 0.4. Now, you might be thinking, well, where'd you get the negative 0.4 and positive 0.4? From the formula. Z equals, remember, z equals x minus mu over sigma. And so when x is 30, it's 30 minus 30.5 over 1.25, which is negative 0.4. And for this limit, it becomes z equals 31 minus 30.5 over 1.25, which is positive 0.4. So that's where these limits come from. Now, how do I find this answer? Well, this comes from table 2. Now that we have our limits in z, we have our standard normal curve, where the mean is 0 and sigma is 1, and this is z. And what I want is the area under the curve between z equals negative 0.4 and z equals positive 0.4. What is that area? Well, that's going to come from table 2. So you get out your table 2s and find the area to the left of the upper one, the upper z, and subtract off the area to the left of the lower z. Please do not subtract the z-scores. Do not subtract the z-scores. I'm begging you. Find the areas to the left of the upper and the left of the lower from table 2. Then subtract the areas. Well, how do I find the areas to the left of each of those z-scores? Well, I go to table 2. And the area to the left of the upper one, I find the first two digits, 0.4, and then the third digit, 0. And the area to the left of positive 0.4 is 0.6554. Now, I find the area to the left of negative 0.4 from table 4. And I find that area is 0.3446. And I subtract the areas. Did I mention? Don't subtract the z-scores. Did I mention that? I think I did. Subtract the areas from table 2 to find the area between two values. So I subtract these, and I get 801. Okay. So the answer is 0.3108. That's the answer. That's the probability that a randomly selected dom-dom has a lifetime between 30 months and 31 months. Now, part C. What's the probability a randomly selected dom-dom has a lifespan less than 24 months? So, here's the question. What's the probability a randomly selected dom-dom has a lifetime less than 24 months? I convert this x value to a z. And if I do that, I'll find that it's negative 5.2. When x is 24, z is negative 5.2. Because the formula is z equals x minus mu over sigma. So it's 24 minus 30.5 over 1.25, which is negative 5.2. So I need to find the area to the left of negative 5.2 from table 2. Now, here's the tricky part. Negative 5.2 is off the chart. What do we do? Lancers? If it's off the chart negative, which it is, the answer is 0. Okay? If you find a number that's off the chart negative, notice how the chart only goes up to negative 3.49. I'm sorry, 3.9. The chart only goes to negative 3.9 and positive 3.9. So this one is beyond the lowest value. So the area is 0. And area is probability. Proportion. By the way, what if the question said this? What's the probability that a randomly selected dom-dom has a lifespan greater than 24? What do you do when this is greater than? That means to the right. Well, that means you subtract the area to the left from 1. And so it would be 1. If the question asked, what's the probability? It's greater than 20. Now, of course, the question wasn't that. The question was less than. So the answer, according to your review, was 0. Good. Now, part D is called percentile. Percentile. And the question is, what is the 95th percentile? Well, here's how to find percentiles. Take the percentile number, convert it to a decimal, and scan table 2 for a 5-digit decimal as close as possible to that number. Well, if you scan table 2, you'll find two numbers equally close. You'll find 0.9495 and 0.9505. You can pick either one. Okay? So, let's say you picked 0.9495. Then find the z-score that corresponds to that. And that is z equals 1.64. So this is a reverse lookup. We're scanning table 2 for the percentile as a decimal. Then finding what z it corresponds to. We're working backwards from the way we usually use table 2. So z is 1.64. Then we use the formula x equals mu plus sigma z. And mu, again, is 3.5. Sigma is 1.25. And z, we said, was 1.64. And if you do this out, you'll find that the percentile, the 95th percentile, is about 32.6 months. Now, what does that mean? Well, it means that 95% of the dom-doms have a lifespan shorter than 32.6 months. That's what that means. 95% have a lifespan shorter, 5% have a lifespan longer than that 95th percentile. So that concludes question 2.